welcome to our fourth and final video for our 5-4 video series. Now, sometimes when you're dealing with these quadratics, you may end up with some extra variables. You might have more than just your x and your x squared, or your t's and your t squareds, depending on what type of problem you're working with. And if you remember all the way back to Unit 1, and I know that's a long time ago, but when we were talking in Lesson 1-7, we talked about literal equations. And literal equations are equations that have two or more variables. And when we were doing Lesson 1-7, we followed all the same steps that we followed for solving an equation. We just were not able to combine and simplify quite as much as we would if we had actual numbers, because we didn't have as many like terms. We're going to use that same process here in literal equations that are going to deal with quadratics. We're still going to use inverse operations to get things by themselves, just like we did in our literal equations for 1-7. We just are going to start incorporating the square root into some of these. So let's go ahead and jump into some examples. So in example 6, we are given h is equal to negative 16t squared plus v naught t plus h, and we are asked to solve for h naught. So we want to get that h naught all by itself. So to do that, we have to move everything else that's on that side of the equation to the other side. So to start off with, I see that I have a negative 16t squared. So to move that to the opposite side, I would add 16t squared to both sides. Now, when I do that on the left side, I have the h and I have the 16t squared. So those are not like terms, so I cannot actually combine those. So I'm going to leave this as 16t squared plus h. We can't simplify them, so we'll just leave them as is. Now on the right, that's going to leave me with v naught t plus h naught. Now I'm still trying to get that h naught by itself, which it is not quite by itself yet, so I need to do another step. I'm going to subtract that v naught t from both sides. And if I look on the left side, I am going to see that I still don't have any like terms, so I will just write these together. 16t squared minus v naught t plus h is going to be equal to h naught. Now you may put these in a different order. Typically we are going to start with the highest variable and move down to the lowest, but because addition is commutative, you could have had these three in any order as long as they keep their original sign. So that is as simple as we can get this, and although it looks very ugly still, we are going to go ahead and call that our final answer. Let's go ahead and look at example 7. In example 7, we are asked to solve for r. So this time we need to get r by itself. And if you'll notice, it has that squared on it, so we're going to eventually at some point have to take the square root to get rid of that. In our last problem, the term we were looking for did not have the squared. The squared was on another term, so we didn't have to take the square root. This time the squared is actually on the term we're looking for, so we will need to take the square root. So we need to get r by itself. So I am going to try first to clear out this fraction. So to clear out this fraction, I have 1 over 3. I can clear that out by multiplying both sides by 3. So that will give me 3v is equal to, and then the 1/3 and the 3 will cancel, and that will still give me pi r squared h. Now when I think about what operation I'm doing here, this is pi times r squared times h. So I am needing to get that r squared term by itself so that I can take the square root. So to get rid of the pi and the h, I am going to use the inverse of multiplication, which is division. So I'm going to divide both sides by pi h. Now on the left, we don't have any like terms that we can simplify, so this is going to be 3v over pi h is equal to r squared. And I'm going to rewrite this up here just where I have a little bit more room. Now notice we have the r squared all by itself, but we need to get rid of that squared. So to do that, just like we did in the problems that had actual numbers, we're going to take the square root of both sides. We're going to have to put the plus or minus square root in front of that left side. So we have plus or minus the square root of 3v over pi h. And then on the other side, the square root and the square symbol are going to cancel, and we're just left with r. So r would equal plus or minus the square root of 3v over pi h. We double check just to see if there's anything that we can simplify under there. The only number that we have is 3, and 3 is prime, so that is not going to be something that we can simplify. And we don't know what v and h are, so those won't simplify. And we know that pi is definitely not a perfect square because that's an irrational number that goes on forever. So our final answer will just be r is equal to plus or minus the square root of 3v over pi h. There are no U tries for this video either. Go ahead and attempt the practice. Make sure that you're checking your practice in the key either on the website or in the classroom. Make sure you ask your teacher any questions that you have, and then prepare yourself for the mastery check. All right, we'll see you in the next lesson.